All right, let's look at our problem here. So we have a position function, and we want to find three things. First, we want to find the average velocity on this interval 1 to 4. Second, we want to find the instantaneous velocity at a specific point, 2.1 seconds. And 3, we want to find the acceleration at this point, 1.5 seconds. All right. This problem gives us a good opportunity to look at the difference between the average velocity and the instantaneous velocity. So let us look at an illustration. Here's our function. And for the average velocity, we want to look at these two endpoints. So t equals 1, t equals 4. We don't care, actually, what happens in between. We just need the two endpoints. And the way to calculate the average velocity is the change in distance divided by the change in time. Okay, if you think of it in terms of the xy axis, it's the change in y over change in x. And that should sound familiar because it's the slope of the line. So if we can just calculate the slope of this line, that's our average velocity. All right. So change in y over change in x. We calculate the function at 4 and at 1. The difference is the numerator. Denominator is 3, and our average velocity is 25 meters per second. Okay. Instantaneous velocity now is at a specific point. Okay. So the instantaneous velocity is the slope of the tangent line. And how do we calculate that? We calculate that with the first derivative. So the value of the first derivative at this point is the slope of the tangent, which is the velocity, instantaneous velocity. So we need the first derivative. That's quite easy to get. 12t minus 5. Then we put in our points, 2.1, and calculate it. We get 20.2 meters per second, instantaneous velocity. Okay, acceleration now is just the second derivative of the position function. Second derivative, again, it's an easy derivative to calculate. It's equal to 12 meters per second squared. And notice that that is constant, does not depend on t. Okay, so at any point, that is the acceleration, 12 meters per second squared. Okay, I hope that was helpful.